All right, so today we're talking about three-step stoichiometry. Now it's very similar to the two-step. It's actually the two-step, but instead of going from mole A to mass B or mass A to mole B, what happens if you have a problem where you're given grams of one compound, you need to find grams of another. So you need to go from mass A to mole B on your mole island sheet.
Okay, so let's go ahead and do some practice problems of three-step stoichiometry. Now again, it's like two-step stoichiometry, but we're going from mass A to mole A all the time. Mass A to mass B all the time. So the problem that we have here is how many grams of Sn at F2 are produced from 30.00 grams of HF. And here's the chemical reaction we're going to need for this problem. Again, first thing first is to identify what we're given and what we are trying to find. So we are given 30.00 grams of HF, so we'll circle that. And we are trying to find grams of SnF2, so we'll go ahead and underline that. So we have grams of one compound, we're trying to find grams of another compound, so we know we're always going to start at mass A, and we're going to end at mass B. Okay? So first step, always when we calculate these, is to start off with what we're given, what we just circled, which is our 30.00 grams of HF. And our times in our line. Now looking at your mole island sheet, we're going from mass B to we're going from mass A to mass B. That is 3 steps we need to take. So we're going to do 3 of these times the line. So our first one, we got mass A go to mole A. And if you look at that arrow going from mass A to mole A, it says that 1 mole is on the top and molar mass is on the bottom. Now we got to find the molar mass of the compound we have in this calculation, which is HF. So let's go ahead and find the molar mass of that compound. So we got to find the molar mass of HF. So if you look on the periodic table, atomic mass of hydrogen is 1.01. And there's one of them in the compound, so we'll multiply that by 1. And then if you look on the periodic table, the atomic mass of hydrogen is 19. And we have one of them in the compound, so we'll multiply that by 1. And then when you plug that into your calculator, we get 20.01 grams per mole. And that 20.01 goes underneath. And in that step, what cancels out is our grams. So now we have moles of HF, but that's not what the problem's asking us, so we got to continue on. Now with this step, we just ended at mole A. Now we got to go to mole B, and that step on the mole island sheet says mole ratio. Again, mole ratio is a conversion between compounds. The compound we want to get to is on the top, and the compound we want to get rid of is on the bottom. So we want to get rid of HF. We don't want that anymore. It's not what we're asking, so that's going to go on the bottom. And our problem's asking us to find SnF2, so that has to go on the top since we want that. Again, to get these numbers, we look at our reaction to figure out the coefficients. So for HF, there's a coefficient of 2. And then SnF2, I don't see a coefficient, so that's going to be 1. Okay. And in that step, our HFs are gone. So what's left, we have mole of SnF2. We need to look for grams, so we got to do another step. Now in this step right here, we just ended in mole B. Now we got to get a mass B. So if you look on the mole ratio of the mole island map, 1 mole is on the bottom, and molar mass is on the top. Now we got to find the molar mass of the compound we still have in this reaction. Well, we no longer have HF because that was canceled out. The only compound we have is SnF2, and that is the compound we got to find the molar mass for here. So let's go ahead and do that. So looking on the periodic table, the Sn, so that's tin, atomic mass is 118.71. There's only one of them a compound, so we'll multiply that by 1. Looking on the periodic table, our atomic mass of fluorine is 19. And we have 2 of them in the compound, so we'll multiply that number by 2. And when you go ahead and do that calculation, we get, let's see, .71 grams per mole. And that number goes on top of here. So on that step, our moles cancels. So what we're left with is grams of SnF2, and that is what we're asking us to find. So we can go ahead and do this calculation, okay? Now again, for you to do this calculation, there's 2 ways you can do this. Take 30 times 1 divided by 20.01 times 1 divided by 2 times 156.71 divided by 1. It's one way you can do it. Just multiply the top, divide the bottom, multiply the top, divide the bottom, multiply the top, divide the bottom. Or you can multiply all the tops, make sure you have parentheses around them on your calculator, and then divide, multiply all the bottoms, make sure there's parentheses around those. So there's 2 ways to do that. So when you do that on your calculator, you get 117.47376 grams of SnF2. Now, if you give me that answer, you are not going to get it right on the homework. It's going to be wrong because, again, we got to do sig figs. So we got to round our answer to the number of sig figs we start with. So looking at 30.00, we know 3 is significant, but are these zeros significant? Yes, they are, because they're after a significant number and there's a decimal point in the number. So we have a total of, not 3, we have a total of 4 sig figs. So we got to round our answer to 4 sig figs. So we'll underline the first 4, the 1174, that's our first 4. This 7 tells me the 4 goes up. So your final answer is 117.5 grams of SnF2. And that is your final answer. Okay, so let's go ahead and do another one of these examples of 3-step stoichiometry. So in this problem, it says how many grams of C2H5OH are produced from 500 grams of C6H12O6. Fun fact, that is sugar. And here's our chemical reaction we're going to need for this calculation. Very first step is to always circle what we are given, underline what we're trying to find. So we are given 500 grams of C6H12O6, and we are trying to find our grams of C2H5O2. We're given grams of one compound. We need to find grams of another compound, so we know we're going to start at mass A, and we're going to go to mass B. So, to start off with these calculations, we have to start out with what we are given. So what we are given is our 500 grams of C6H12O6 times in the line. Now looking at your mole island sheet, if we're going from mass A to mole B, that is going to be 3 steps. So we got to take one step at a time. So our first step, we got to go from mass A to mole A. And when you look on your mole island sheet, it says that 1 mole is on the top and molar mass is on the bottom. Well, we got to calculate the molar mass of the compound that we still have in this calculation, which is C6H12O6. Let's go ahead and calculate that molar mass. So the molar mass of C6H12O6. Now looking on the periodic table, the atomic mass of carbon is 12.01. And we have 6 of them in the compound, so we'll multiply that number by 6. Looking on the periodic table, our atomic mass of hydrogen is 1.01. And we have 12 of them in the compound. And then looking on the periodic table, the atomic mass of oxygen is 16. And we have 6 of them in the compound, so we'll multiply that by 6. So when you do that, you will get 180.18 grams per mole. That 118.18 is going to go on the bottom. And in that step, what is canceled out now is our grams. So what we're left with is moles of C6H12O6. Well, that's not what we're trying to find, so we got to go and continue on. Now, in this step, we ended at mole A. Now we got to go to mole B, and that step says mole ratio, and that's the conversion between compounds. The compound we want to find is on the top. The compound we want to get rid of is on the bottom. So we have C6H12O6. We do not want that because we want C2H5OH. So C6H12O6 is on the bottom. And we're trying to find C2H5OH. So that's going to go on the top because we want that one. Now we got to look for these numbers, and that's the coefficient of the reaction. There's a 2 in front of C2H5OH, so that 2 goes here. There is no number in front of C6H12O6, so that's just going to be 1. And now in that step, our C6H12O6 is gone. Now what's left with is moles of C2H5O2. Our problem's asking us for grams, so we got to do another step. And we just ended at mole B. Now we got to go to mass B. And that step says molar mass is on the top and 1 mole is on the bottom. And we got to find the molar mass of the compound that we still have in the reaction. Well, we got rid of C6H12O6 that no longer exists. So the compound we have now is C2H5OH. And that is a compound we want to find the molar mass of. So let's go ahead and find the molar mass of that compound. Looking on the periodic table, the atomic mass of Carbon is 12.01. We have 2 of them, so we'll multiply that by 2. Looking on the periodic table, our atomic mass of hydrogen is 1.01. Now we have 5 here, and we have 1 at the end, so 1 plus 5 is we have a total of 6 hydrogens in the compound. And then looking on the periodic table, our atomic mass of oxygen is 16. And we only have 1 of them in the compound, so we'll multiply that by 1. So if you go ahead and do that in your calculator, you get 46.08. And that number goes on the top here. And with that step, our moles are canceled. Now we're left with this grams of C2H5OH, and that is what we wanted to find. So we're good to go ahead and calculate it. Again, 2 ways to do that is 500 times 1, divide, multiply, divide, multiply, divide, or multiply all the tops, then multiply all the bottoms and divide those 2 numbers. 2 ways you can do that. Those will work perfectly fine. So when you go ahead and do that on your calculator, we get 255.744 grams of C2H5OH. But if you give me that on your homework, you will be wrong because we got to do sig figs. So the number of sig figs we start with is the number we should end in. So looking at 500, we know 5 is significant, but are these 2 zeros significant? No. Yes, it's after a 5, but is there a decimal point in the number? No. So those numbers are not significant, so we only have 1 sig fig. Now, since we have 1 sig fig, we've got to round our answer to 1 sig fig, so we'll highlight our first one, which is 2. Our 5 tells me our 2 goes up, so it becomes a 3. But does 255 make sense rounding up to 3? No. Since these 2 5s are whole numbers and we're getting rid of them, we'll just simply put zeros. So it's 300 grams of C2H5OH. And that is your final answer.